All right, here we are. We're back on page 3, definitions of 3 common quantities. We're going to define these 3 common quantities and then switch over and do some other stuff. So here it is. We're going to define mass, distance, and time. And these are pretty well, I'm not sure about straightforward, but hopefully definitions that you've seen before. Mass, this is the amount of substance or the amount of stuff in an object. So it's the amount of stuff, a lot of times we call that matter, in an object. All right, its base unit is the kilogram, and now we know why the base unit for mass is kilogram, because we don't have a gram of anything sitting in Paris. We have a kilogram of mass sitting in Paris. So that platinum iridium little plum-sized thing that you saw in the previous video, that was a kilogram. So that's why we use it. So we have other secondary units. So gram, we can do centigram, and you can go on forever with those. Distance, this is how far. Okay, so simply how far. How far it is to travel from one place to another. How far it is between two different points. Base unit in the metric system is going to be the meter. We have centimeter, all different kinds. Millimeter, hectometer. We'll go through all these individual ones on the next video probably. All right, the next one, time. I think time's a harder one to define. Time is the forward flow of events. We measure it in seconds. We can do minutes, hours, days, times, all that stuff. All right, so what we're going to do next is this. We're going to slip over, and you should have a copy of what's called your dimensions and units sheet. And it looks like this. This particular one is yellow. Yours may not be yellow. And I'm not going to spend the whole video going through all these. I'll let you spend. I'll do this one with you, and then probably skip over the other ones. But I'll use this particular time to kind of explain what you're doing. There's 3 columns. There's dimensions, units, and governing equations. And when you're instructed to record mass, distance, and time, as well as the 4 fundamental units, 4 fundamental dimensions of the SI system on your dimension, that's basically filling this out. So what we're going to do is this. We're going to start with length. And instead of writing length, we're going to actually use distance, because that'll be actually pretty important to us later on. So there's distance. You can use length for now, but we would prefer distance, and later on distance will be the only one that we can use. We measure distance in meters, centimeters, miles, inches, and so forth. So that you can go on forever with that. This particular one, there's no governing equation, so you don't have to worry about that one. All right, the next one, I'm just back in your notes. We just did length. Now we're going to do mass. This is page 3 of your notes, and I'm just going to go all the way down. All right, so mass is kilogram. You can put gram. I would also put slug. That'll be important. There's no governing equation for this one. Just going down the list in your notes. The next one is time. So we get seconds, minutes, hours, days, so on and so forth. And there's no governing equation there. I do want to go backwards. Back up to distance. Put down the light year, if I can spell it. Under distance, light year is a measurement of distance. Some people think it's time, but actually light year is the distance that light travels in 1 year. And so that's where they get light year from. But we'll come back to that and talk about that in a little bit more detail. All right, I'm just going to continue in your notes. So we have electric current. And electric current is amps. No governing equation. Really no governing equation on any of these that we're going to be concerned about. Temperature is the next one. Kelvin, you can do Celsius, you can do Fahrenheit. No governing equation there. Amount of substance. And that is the mole. No governing equation there. And the last one, luminous intensity, and that's candela. And so when you're instructed to in your notes to fill out your units sheet, then that's what you're doing. And this will be probably one of the more valuable things that you'll hang on to throughout the year. And I would recommend that if they give you a plastic sleeve for it, just simply slide in the plastic sleeve and you'll have it handy. You will use this all the time. All right, so back to your notes. Flip the page, and we're on page 4 now. So we're going to go to derived units, and we'll give you a quick definition and then run through a couple examples for you. All right, derived units, these are, if I can find them in my notes, units that may be expressed in terms of combinations of base units. That's combinations. So we have fundamental units, which are the 7 that we just did. If we take those 7 units and multiply them and divide them, we get what are called derived units. And as soon as you see a couple examples, you'll catch on to this very fast. Area is one example. If you can just remember an easy equation for area, area is simply length times width. And so we know that length, we just did this, is meters, and width is meters, and meters times meters gives us meters squared. So when you see meters squared, that means that you have a unit of area. So the dimension would be area, and the unit would be meters squared. We could do inches squared, yards squared, miles squared. Basically, anything squared is going to be, or any length squared is going to be area. Moving along, volume. You guys know that volume, or at least I hope you know, volume is length times width times height, so that'll be a meter times a meter times a meter, and meter times meter times meter is meters cubed. So that's volume. And we also have some other ones. Liter would be volume. Gallon would be volume. So volume is kind of a trickier one. Another one, these are all examples of derived units, would be density. And density is mass divided by volume. So now we know mass. Mass was kilograms from earlier, and volume, we just did, is meters cubed. So there's density, kilograms per meter cubed. And the last one we're going to do, just so you're aware of it and you see it one time, is weight. And weight is going to be mass times what's called the acceleration of gravity. And I'm not too concerned that you understand the whole thing here, but mass would be like kilograms, and then gravity is actually a meter per second squared. We'll get to that later on. And if we put all that together, we get what's called a Newton. All right, so in your notes, we've got a demonstration, and I'll talk about the demonstration. I won't actually do it in a video here. If you take a loaf of bread and open it up, and take the loaf of bread and literally just squish it all the way down, smush it all together. One thing changes when you do that, and one thing stays basically the same. So the question is what changes and what stays the same? Well, the amount of stuff inside the bag really doesn't change if you ignore the air that's escaping. But the bread that's there stays the same, the amount of bread that you have. So the mass of the object stays the same. So that's what stays the same. And then the volume of it actually goes down. So it still has the same amount of stuff in there if you ignore the air that's escaping. And its volume shrinks. It takes up less space. So those are derived units. And what I'd like you to do next is, and I'm going to let you do this one on your own. You can pause the video if you'd like. Go back to the yellow sheet that we went through and basically include those 4 units. So we'll do area, volume, density, and weight. And each of those has a governing equation. So area would be length times width, and then you can go through and do the rest of them on your own. So I'm going to let you do that. You can pause the video and finish those off if you'd like. All right, so the next thing on the video is a practice quiz. And I would recommend that you pause the video and actually do these on your own. Before you do that, though, how about we do 1 or 2 of them just so you get a feel for what you got to do, and then you can practice them and then see if you got them right. So let's do the first line together at least. So if I say meter, meter measures what? So meter is like a unit. Meter measures distance. So there's distance. Mole, If you can look back, so this this is where the yellow sheet's going to be very, very handy. Mole sits right down here, and so mole is amount of substance. So we'll put, needs to have longer blanks there. Light year is the next one, and so light year is right here, and that goes with distance. Don't put time for light year. And now just go ahead and finish them out. I didn't leave room for you so you can see that. There's distance. So go ahead and stop the video, answer the rest of those, and then you can come back and see if they're right. So here are the answers. Candela is luminous intensity. Celsius is temperature. Kelvin is temperature. Ampere is current. Hectogram is mass. Don't let the hecta mess you up. All you're really concerned about is the gram that's on there. If you can get the gram and see the gram and notice a gram goes with mass, then you're home free. Don't let the prefixes mess you up. Here's a tough one. Meter squared is area. Let's see if I can zoom in here a little bit and give you a chance at seeing some of these. Liter, we talked about that one. That's volume. Day, you should know that day is time. And then gram per milliliter. So that's a tough one. Let's see if we can think it through. Gram is mass. Milliliter, volume. Remember back up here? Density is mass divided by volume. So this one is going to be density. And these are all, actually let me come back to these are back up here, these are all derived units because we're multiplying or dividing one or more fundamental units together. And there's your quiz. So hopefully you did well, and we'll see you on the next video.